Hello everyone, my name is Shyam Chauhan and in this lecture we are going to cover topic number 2.3 relationship between zeros and coefficients of polynomial. Let us understand few terms, that is zeros and coefficient of polynomial. We know that polynomial is of three types, that is first is linear polynomial, that is of the form p of x equals to ax plus b. Then we have quadratic polynomial, that is of the form p of x equals to ax square plus bx plus c. And third we have cubic polynomial, that is of the form p of x equals to ax cube plus bx square plus cx plus d. And the coefficients are the a, b, c and d in each polynomial. And the zeros of polynomial p of x. To find the zeros of polynomial, what we do is we put p of x equals to 0, and in next step we find x which satisfy p of x equals to 0. We have already seen for linear polynomial which is of the form p of x equals to ax plus b. If we find the zeros of the polynomial, that is if we put p of x equals to 0, that is ax plus b equals to 0, we get x equals to minus b upon a, that is also the constant term divided by the coefficient of x. Today we will learn zeros of quadratic polynomial and relationship between zeros and coefficient of quadratic polynomial. We have to find p of x equals to 0, and for quadratic polynomial we know that p of x equals to ax square plus bx plus c. So we have to find ax square plus bx plus c equals to 0. Now we have to find the zeros of polynomial. I can put ax square plus bx plus c equals to some constant k in bracket x minus alpha into x minus beta, where alpha and beta are factors of quadratic polynomial. Let us understand why I have put this equation. You have already learned how to find the factors of quadratic polynomial. Let us take one simple example, that is 2x square minus 8x plus 6 is the given quadratic polynomial. Now to find the factor, we have to put p of x equals to 0, that is 2x square minus 8x plus 6 equals to 0. Now the important step to find the factor is first make coefficient of term x square equals to 1. That is, we have to make this as 1. So what we will do is divide both the sides by coefficient of term x square. If we divide, what we will get is 2x square divided by 2 is x square minus 8x divided by 2 is 4x and 6 divided by 2 is 3 equals to 0 divided by 2 is 0. Now what we will do is we will factorize this constant term into the form such that it makes the 4 by addition or subtraction. We can get 3 by 3 into 1, we will get 3, and if we add 3 plus 1, we will get 4, and if we want minus 4, what we will do is minus 4, that is minus 3 minus 1, we will get minus 4, and if we multiply minus 3 into minus 1, minus 3 into minus 1, we will get 3, that is minus into minus is plus, so 3 into 1 is 3, we will get plus 3. So if I factorize this equation such that I will get by the multiplication the constant term, and by addition I will get the coefficient of x. So I can put x square minus 3x minus x plus 3 equals to 0. If I take x as common from first two term, I will get x in common, remaining is x, and here remaining is minus 3, and again I will take minus 1 common from the second term, I will get x minus 3. Why I have taken minus 1? Because I want to bring minus 3, x minus 3, so that I can take x minus 3 again common from both the terms. Now I will take x minus 3 common, that is x minus 3 in common, remaining is x here, and minus 1 here equals to 0, and the 2 is as it is in all the terms. So if I put x minus 3 equals to 0 and x minus 1 equals to 0 in this equation, in this polynomial, I will get p of x equals to 0. Let us take the original polynomial, that is 2x square minus 8x plus 6. P of x equals to 2x square minus 8x plus 6. That is, if I put x equals to 3 and x equals to 1, that is for p of 3, if I put x equals to 3, 2 into 3 square minus 8 into 3 plus 6, that is equals to 9 into 2 is 18 minus 24 plus 6 equals to 0, and for x equals to 1, I will get 2 into 1 square minus 8 into 1 plus 6, that is equals to 2 minus 8 plus 6 equals to 0. So these are the zeros of polynomial. Why I have done this? Because I want to bring the form such that k into the zeros of polynomial. So for the quadratic polynomial, I can write in the form k into x minus alpha x minus beta. I have taken the example, that is, I can write polynomial p of x equals to 2x square minus 8x plus 6 in the form k into, I have taken here, that is k into x minus alpha into x minus beta, where alpha and beta are the zeros of polynomial. We have checked here that x equals to 3, that is alpha equals to 3, beta equals to 1, and they are the zeros of polynomial. X equals to 3, x equals to 1 are the zeros of polynomial. P of x equals to 3, p of x equals to 1, where p of 0, p of 3 and p of 1 we get the 0. So 3 and 1 are zeros of polynomial p of x. So I can write the polynomial of the form ax square plus bx plus c equals to k into x minus alpha x minus beta as the zeros of polynomial. I can also write alpha and beta are zeros of polynomial. Now simplifying the right hand side, that is ax square plus bx plus c equals to k in bracket x into x is x square minus beta x minus alpha x plus alpha beta, that is equals to k into x square minus in common x in common, I will get alpha plus beta into x plus alpha beta. If I multiply k inside, that is kx square minus alpha plus beta into kx plus alpha beta k, that is equals to ax square plus bx plus c. Now comparing the coefficients of x square, x and constant term, what we will get is a equals to k, a equals to k, b equals to minus of alpha plus beta k, and constant term equals to alpha beta k. Now I can put a equals to k in both of this equation, that is b equals to minus of alpha plus beta k equals to a, that is we have got the relationship between alpha beta and ab, that is coefficients b by a. If I take minus sign here, I will get relationship between coefficients and zeros of polynomial. From this I can get c divided by k equals to a, that is k equals to a, I have put in this equation, that is equals to alpha beta, that is product of zeros of polynomial, and here it is sum of zeros of polynomial. So I can write alpha and beta, that is alpha comma beta are the zeros of polynomial, and a comma b comma c are coefficient of quadratic polynomial. I will get the relationship between coefficients and zeros of polynomial, that is product of zeros of polynomial equals to c by a, that is alpha beta equals to c by a, that is product of zeros of polynomial equals to c is constant term. If I write the polynomial equals to ax square plus bx plus c is the constant term, and divided by a is the coefficient of x square, coefficient of term x square. If I see the sum of zeros of polynomial, that is equals to minus b divided by a, that is sum of zeros of polynomial equals to minus b divided by a, that is equals to minus of coefficient of term x minus of coefficient of term x divided by coefficient of x square. So these two are the important formula of relationship between zeros and coefficient of polynomial. Now let us check the theory. They have taken the example, that is 2x square minus 8x plus 6. They have taken 2 in common, x square minus 4x plus 3. Then divide 3 into the form such that we can get by addition or subtraction the term, that is the coefficient of x, that is minus 3 into minus 1 we will get minus 4, and product we will get is 3. So they have written x minus 1 x minus 3, and 1 and 3 are zeros of polynomial. Now the sum of 0 are 1 and 3, alpha comma beta are 1 comma 3. So sum is 4, that is equals to minus of b by a, that is minus of b is coefficient of term x, that is minus 8, and divide by a, that is coefficient of x square, that is equals to the 4, which is sum of zeros of polynomial, and product, that is equals to 1 into 3 equals to alpha beta, alpha plus beta equals to minus b by a, alpha beta equals to c by a, that is c is the constant term ax square plus bx plus c. It is the quadratic polynomial, so c is the constant term, that is 6 in this case. 6 divided by a is coefficient of x square, that is 2. We get the same result, that is alpha into beta equals to c by a. They have derived the proof of alpha plus beta and alpha beta, that is relationship between zeros, that is alpha and beta, and coefficient, that is a comma b comma c of quadratic polynomial. Now let us see the example 2. We are given with the quadratic polynomial, that is x square plus 7x plus 10 is the polynomial. We have to first find the coefficient, that is a, b and c, and alpha beta. We can find ABC by just looking at the polynomial, that is a is the coefficient of x square, ax square plus bx plus c is the standard quadratic polynomial. A is coefficient of x square, that is 1, b is coefficient of x, that is 7, c is constant term, that is 10. Now we have to find the alpha beta, that are the zeros of polynomial, that is x square plus 7x plus 10 equals to 0. We will get the zeros of polynomial. We have to divide 10 such that we can get the coefficient of x, that is 7. If we divide 10, that is equals to 1 into 10, we cannot get 7. 1 plus 10 is 11, minus 1 minus 10 is minus 11. We cannot get 7. If we take 2 into 5, we will get 2 plus 5 equals to 7. So we can divide 10 into 2 into 5 to find the zeros of polynomial. So factorize 7x equals to plus 5x plus 2x plus 10 equals to 0. From first two term, take x as common, x plus 5. From second term, take 2 as common, you will get x plus 2 5s are 10, that is equals to 0. Now both the term, take x plus 5 as common, in bracket x plus 2, that is equals to 0. Now if you put x plus 5 equals to 0 or x plus 2 equals to 0, we will get the zeros of polynomial. That is, if we put x equals to minus 5 or x equals to minus 2, these are the zeros of polynomial. So zeros are the same as alpha and beta. So we got the alpha and beta, that is minus 2 and minus 5. We got ABC equals to 1, 7 and 10, and alpha beta equals to -5 and -2. The polynomial was x square plus 7x plus. Now verify the sum, that is equals to minus b by a. We have LHS equals to alpha plus beta, that is equals to -5 -2 equals to -7, and if we see right hand side, that is equals to minus b divided by a, and b is 7, a is 1, so we can get minus b is 7, a is 1, that is equals to -7. So we have LHS equals to RHS. For product of zeros of polynomial, alpha beta equals to c by a, we have LHS equals to alpha is -5, beta is -2, that is equals to minus into minus is plus, 2 into 5 is 10, and right hand side equals to c by a, that is equals to c is 10 and a is 1 in this case, so c divided by a, that is 10 divided by 1, that is equals to 10. So we have LHS equals to RHS, hence verified the zeros and verified the relationship between zeros and coefficients of polynomial. Now let us see example 3. Example 3, we have to find the zeros of polynomial x square minus 3, that is the polynomial. We have to find the zeros of polynomial and verify the relationship between zeros and coefficients. To find the zeros of polynomial, we will put p of x equals to 0, that is x square minus 3 equals to 0. We will get x square equals to 3, and if we find x, that is equals to plus or minus under root 3. So these are the zeros of polynomial. So note down a, b and c and alpha and beta. Alpha and beta are the zeros of polynomial, that is root 3 and minus under root 3. A, b, c are the coefficient of polynomial, that is ax square plus bx plus c, that is the polynomial. We get a equals to 1. X term is not given, so we can write b equals to 0, because multiplication of 0 into any constant is 0, that is b equals to 0, and c, that is the constant term, that is minus 3. So we have relationship. Let us verify the relationship, that is alpha plus beta equals to minus b by a. We have LHS equals to alpha plus beta, that is alpha is root 3, beta is minus root 3, that is equals to root 3, plus into minus is minus, that is equals to 0. We have right hand side, that is equals to minus of b divided by a, that is minus of b is 0, a is 1, that is equals to 0. Now the product of zeros of polynomial, that is alpha beta, is c divided by a. Alpha is root 3, beta is minus root 3, that is equals to plus into minus is minus, root 3 into root 3 is 3. We have right hand side, that is equals to c divided by a, that is equals to c is minus 3, c is minus 3, a is 1, a is 1, we will get minus 3. We have LHS equals to RHS, hence verified. Hence verified the relationship between zeros and coefficient of polynomial. Let us see example 4. Example 4 is find a quadratic polynomial p of x. We have to find the p of x, that is ax square plus bx plus c. We are given with sum and product of zeros of polynomial are minus 3 and minus 2. We have zeros of polynomial, that is alpha and beta, and coefficient is a, b and c. We have to find a, b, c. We are given with sum and product of zeros of polynomial, that is minus 3 and 2. We know alpha plus beta equals to minus b divided by a, and alpha beta equals to c divided by a. So if I put, if a equals to 1, if I put a equals to 1 in both of this equation, I will get minus b divided by a, that is equals to minus 3. If I put a equals to 1, minus b divided by 1 equals to minus 3, that is equals to b equals to 3. And if I put 2 equals to c divided by a, if I put a equals to 1, I will get c divided by 1, that is c equals to 2. So for a equals to 1, I will get b equals to 3 and c equals to 2. So for a equals to 1, b equals to 3 and c equals to 2. So we have to find the quadratic polynomial, that is 1x square plus 3 into x plus 2. This is the quadratic polynomial. One x square plus 3 into x plus 2 is the quadratic polynomial. In next lecture, we will discuss the relationship between zeros and coefficient of cubic polynomial. Thank you.